Hey there. I wanted to walk you through the first part of 3.4, which is graphing polynomial functions. And in general, our polynomial is going to be somewhat in the shape like this. You could possibly have additional factors here, but we're going to be looking at just some steps that we can do to graph it. One thing that really helps is to kind of know what the general shape of the graph is going to look like. For example, if it's a cubic function, in general, it's going to have kind of this S shape. Now, the S can change a little bit depending on the other parts of the function, but overall, this is going to have more of an S shape, whereas like x to the fourth is going to have more of a U shape. And what you'll notice is, and you can graph these on Desmos too if you need a better picture, is with the odd functions where your exponent is an odd number, you get kind of this S shape. It can change and maybe get a little bit steeper depending on the exponent. And then with the even functions where you've got an even exponent, you really kind of get this U shape, but a lot of times this part in here will maybe flatten out a little more as the exponent gets larger. Just to review some of our prior knowledge of graphing that we've talked about this year, when you're looking at your A value, which is your coefficient, if A is greater than 1, it's a vertical stretch. If A is less than 1, and again, that's between 0 and 1 is what we really want to think about. That's a vertical shrink, and then if A is a negative number, that causes the graph to reflect. For your H value, if H is positive, or you have X minus H, that translates to the right, X plus H translates it to the left. And then K moves it up or down, just like we talked about with quadratics and some of our other functions. One thing that really can help us when it comes to graphing polynomials is to figure out what our ends are going to do in the first place. And that's really what this section is looking at. What you want to look at is the degree of your function, that's the biggest exponent, and then the sign of the lead coefficient. And so this really kind of tells us what we can do with our exponents. So there's this information here, but then over here, I think this really helps me. If you've got an odd degree, like x to the third, what you'll notice is that your ends go in opposite directions. Either the left side's going down and the right side's going up, or vice versa. And which direction it's going in depends on whether the lead coefficient is positive or negative. So if your lead coefficient is positive and it's an odd degree, the left side is going to be going down, the right side is going to be going up. If your lead coefficient is negative, it reflects that, and they go in the opposite directions. If you have an even degree, which means you have an even exponent, what you'll notice is both ends go in the same direction. Either they're both going up if your lead coefficient is positive, or they're both going down if your lead coefficient is negative. And that's really what this section is summarizing. So I find this probably more helpful when it comes to end behavior. And so what I'd like you to look at today is really just the basic steps on how to graph a polynomial function. First, the first thing you're going to want to do is to find the real zeros of your function. This is what we did in section 3.3. Come up with all the possible rational zeros, and then choose one, aka use your graphing calculator to help you pick some to get this function f completely factored. That will allow you to find your zeros or your x-intercepts. Another great point to find is your y-intercept. What's the value when we plug in 0 for x? That's another point you have. And then after that, once you have your x-intercepts and your y-intercept, pick test points between your zeros or between your x-intercepts to kind of figure out the rest of the shape of the graph. In addition, also look at your end behavior. What should the ends be doing? Because basically what we're going to do is we're going to get a sketch of the middle using these points, and then we're just going to finish this off with what we know our ends should be doing. So if we look at this first example, here's our function. And the first thing I did is I looked at my lead coefficient, which is positive, and my degree, which is odd. Well, if I have a lead coefficient that's positive with an odd degree, what that's telling me is my ends are going to look like this. Going to the left, it will be going down, and going to the right, it will be going up. So I know that's what my ends should do. So then I start finding my real zeros. And this is where we would list out all of our combinations of P over Q. And remember, Q comes from, no, excuse me, that's wrong. Q comes from the lead coefficient, and P comes from your constant. So it's all the combinations of factors of P over factors of Q. If you need to look at that, go back to section 3.3. And then from there, we would guess a factor, aka graph our function, and pick a 0 off of the graph. Again, I do want to see the work. And so I guessed that 1 was a 0. And when I divided that out, I did get a remainder of 0, so I know I was right. And since I started with a cubic function, I ended up with a quadratic. So at this point, I'm right here, and then I just factored this into 2 linear factors. And I was able to figure out that my zeros are 1, -3/2, and -2. And so I plotted those on the x-axis. Then I found the value of my function when I plug in 0 for x, and I end up getting a y-intercept of -6. So there's another point I have. So then I came over to my xy table and use as many as you need to. Pick a few, I say pick within and pick without. So I picked a couple values. So -2 is a 0, so I picked a couple values on this side. I tested -4 and -3. It's a little tricky here, but between -2 and -1.5, I wanted to just pick something so I could know what's going on between there. So I picked -1.75. Then I also picked, and I had a point here at 0, so I had an idea of what was going on. Then I picked 2 and 3 out here just to give me some ideas of what it was doing. And all I did was plug these values into my function, and you can actually use the table function on your graphing calculator or the table function on Desmos to help you find these a little bit faster. And that gave me some points to graph and got me the general shape of my function. And again, notice that my ends are doing what we suspected they would do just from looking at the lead coefficient and the degree. So let's look at another example. So this next example, my function is -x⁴ plus 2. And so I noticed that I had a negative coefficient and an even degree, so both of my ends should be going down. And so then I started looking at finding all combinations of factors of P over factors of Q, and I ended up with this. But for this one, really, it's not necessary, because to find my zeros, I only have one variable in the problem. I can set my function equal to 0, and in this case, I can actually solve for x and figure out what x would make it 0. Okay? And so I end up with positive and negative about 1.18. And that's just the approximate value of the 4th root of 2. Now remember, we're just doing a sketch, so an approximate is fine. So I just went a little bit past -1 and a little bit past +1 to get a good approximation of those two values. I also found my y-intercept to be 2 by plugging in 0. And then again, I picked a few values outside and in between my x-intercepts, and I just used the calculator and plugged those in and found the values so I could get a general sketch of my graph. And again, notice that my ends are doing what I predicted they would based on my lead coefficient and my even degree. So I've left you a worksheet. Please use these notes and go back and watch this again if you need to. Use these notes to help you work on the worksheet. The worksheet is going to be turned in on Monday. So tomorrow you have a work day to finish up any of my math lab assignments and to finish up the worksheet. And again, the worksheet will be turned in Monday. The my math lab assignments are due on March 13th, which is Wednesday next week. Have a great weekend.